position. I'm going to use a uint because we'll never hit 0. And make sure on our init our position is, make sure it's set to 0 just for clarity and completeness. So why is this underlying duplicate class field? Oh, we have a position. So this is clever. I guess I already planned on it. Okay, so that was a pleasant surprise. Like I said, I didn't even look at this over the weekend, really. I mean, I looked at it, but didn't really come up with any major solutions. So it commented a bunch of this out so that we can kind of come back and get this right. So here we are. Where's our update function? Okay, so update, so we're going to read all the bytes. And we're going to get the bytes off of the socket, which is this guy here, and then we're going to set it to our buffer. Now our buffer is, for now, just bytes. And we're just pushing a byte on a position. So what we could do is we can plus our position. And our bytes available we're going to increment. I think our buffer has a length. So we're going to see if that will persist through. So I'm going to kill this. Our buffer is always going to be 1024, so that's not going to work. So bytes available is that. And then our position is incremented. Actually, we probably can't do that. We don't want to increment our position because that's already doing this. So what we can do, which would be better, is we're just going to use position. And then, nope, that's not going to work. Okay, so we're just going to do position is plus equals 2 bytes dot length. Maybe? Okay, no. Okay, so our position once we do update should always be 0. So there should probably be bytes available. Just thinking through it here, so, and then our position will be 0, so we need to set our position to 0. So every time we read, it should set our position to 0, and we're just going to chomp it on the, push it onto the end. One more thing is that we probably need to rebuild our buffer every time. So maybe this is going to be better. So we don't need our input here. Actually, we'll just use an input. And I think, sorry, those are connect. That's okay. Our socket is injected, so socket input. Okay. So here we're going to add the bytes available. Our position is 0. We can clear this out a little bit, and a buffer will be created new every time. So buffer equals bytes allocate. It'll be bytes available plus bytes dot length. Now, one problem we have here is that our buffer's already, well, so we're going to call this our temp buffer. And what we'll need to do is for I in 0 through bytes temp buffer bugger dot length this is going to be bytes. If we, let's see here, if we create a new buffer, so temp buffer dot set position, which is, oh, this is not right. Position I plus, so we'll just do I. We may not need this at all. Okay, so set, which is I, and then the value will be our current buffer get at the same position. So what was on before we pushed on first, and then after that this will be I plus temp buffer dot length, so that's the previous length, and the value. Okay, and now we're going to set our buffer, our temp buffer. So our buffer here is going to be our temp buffer, so we're going to deallocate that, and then buffer set there. And what we can do var temp buffer length uint equals temp buffer length temp buffer length. There we go. Let's see if that does the trick. Alright. So we're building her up. Let's see if that does the trick here. Now it crashed, and so not sure why yet. Okay, so likely is we don't have our buffer instantiated equals bytes alloc, we'll just do 1. So we have one error, we have value of, okay, so our byte buffer, bytes available, which would be our buffer length. And we still have a fail, but we are making progress. We have value of 4 and that equals expected value 3. So let's look here. So it's line 183. So expected, okay, so what we need to do, we can't do this. And we gotta do, we put this here. And we need to check if buffer is equal to, or not equal to null. We're going to do this. And then else buffer equals bytes allocate let's see here. That's wrong. So, but anyways, allocate bytes. Oh, we do need this up here. Bytes dot length. And this one, bytes available, that is going to work there. So we're missing the temp buffer length, which is temp buffer length, temp buffer length. Whoa. It's going to start at 0. Okay, so we're moving on through. So line 184 is expected true, and we got false. Okay, so let's just trace our value here and see what's going on. So it should be 101. Oh, so what we're missing is our position. So here, once we read the Boolean, we're going to have our position increment. And so this is one thing I definitely don't like. So maybe this is the part I don't like here. Because if we read it, we want it to behave like an input. So there's the weather today. Oops. I think after we have it in a, so now we can use a bytes input. We can just pass the bytes in. So let's try that. Let's try. So we may not need this buffer, so we're going to ditch it. So the we'll call it the buffer still bytes input. And what we're going to do here, say bytes buffer here equals new bytes input. And we're going to get the bytes, which is, this is all wrong now. So I wonder what we can do. This is going to go on the end. See here. Bytes input. So we're going to, this is going to be on the end. It feels like, darn it. It feels easier if we had this to deal with. So maybe we'll just create one called bytes. You know, I'm going to go back to buffer on this one, bytes. We'll call this buffer input, bytes input. Okay, so now bytes buffer input, and we're going to pass it the buffer and position and length. So position would be 0 position, and length would be bytes available. So here we have our input. We definitely should be able to clean this up, but let's just run this for now. Let's get our test passing. So 184, we're still, okay, so we're still reading off the buffer, so we want to use our bytes, our buffer input. Our bytes available is being decremented, which I don't think that's accurate anymore. And our buffer input is length of stream in bytes. This may change, may not, so let's look for it. So let's do buffer input. So that did not fare well. Buffer input. Not sure why it didn't. So here's the buffer, position re0, bytes available. So I think that's the issue. Bytes available has not been created yet. So this here would be buffer length. It's only allocating what we need. Okay. Making some type of progress. So here, line 95, we're getting 5. So what we need is bytes available is that. I wonder if we do bytes available plus position. Let's just trace. If we do get position, this is just going to be value. This is going to be the buffer input position. See if that actually changes. If buffer input is null, then return 0. So, oops. As this reads, let's unsend short, read Boolean. What we want to do var ret val turn red val trace position. So it is moving position, so that's great. Okay, so the position is changing. So here, when we allocate our bytes available, or allocate our bytes, we check for the bytes available, which is our current buffer, plus our length. So what we need to do, I'm going to do minus position. So that would give us, take off what we've already read. I think, actually that may not be. What is our bytes available buffer input length? So I wonder if our bytes available is decrementing. So let's go back to this. Trace bytes available, return red val. Sort of playing around with it, making sure we understand what's going on. And so we can do, so yeah, this is always 3. So bytes available would be the number of bytes on it minus the position. And we don't do that anymore. So now it goes 2, 1, and then out of bounds at this thing, which we're not sure why that's happening yet, but we'll track it down. So bytes available here doesn't seem unreasonable. So I'll trace the dating because it didn't crash the program. So yeah, just getting to here, and our bytes allocate, so bytes available minus position plus bytes.length. Let's figure out what this is. So here, it's 1. I feel like the length would be more than that. Let's see here. Let's take a look at bytes allocate 2. So trace bytes length. So here we've got 3 bytes, and then it's 2. I think we actually want to do -1 on this, because position is not 0 based, is it? Let's look. So if we do trace position, so we've got 3 bytes available, so this is line, so this is position 0, position 1 has 2 bytes available, position 1 goes to position 2, so it does increment, and we have bytes available as 1. Yeah, so we have to subtract by 1. So here, it's going to be position -1. And outside bounds. So let's check here. Trace temp buffer length. Oh, know what we need to do? No, that should be okay. Because position gets set back to 0. I think this needs to be actual 0. It's going to be faster anyways, because it doesn't have to reference a variable. It's not inlined. So we're still getting, here we go. So it's not getting the same thing. So let's trace our buffer length. And our buffer length on here is 0, so it's not right. Buffer length was 3 here, which I think is also not right. Temp buffer length. Oh, yeah, that's 0. So let's maybe this is just all sorts of wrong here. So trace, and we're going to trace the bytes length. Okay, so at 104, I think, is this what we want? Nope. At line 104, that goes here, 120. We only hit line 104 once. So we go 115, which is here. Okay. So what is bytes available? Let's just find out what that right now. Let's kill that. Weird. Okay, so line 104, bytes available is 1. And that is fully correct. And then bytes available length is 2, so that is correct. So we don't need to play around with the position. Okay, so now that is a pass. Okay, so that was the problem presented. Okay, let's clear out our logging. Let's go back to our test that we kind of manhandle a little bit. Set those back to here. Okay, so we are running that one. So now, before we close off the day, I'm going to make sure that we should read a byte from the socket. So that should fail. And we'll do a more hardcore test here shortly. That failed. So this here is going to be buffer input read byte. And it crashes. Probably because read byte is not implemented. So let's find out. Read byte. Let's try and read that byte. Catch E trace E return 0. Dynamic. And that is still not working. Is there a test? Oh, it is our test. We need to run input, no, socket stream update. That's our problem. Oh, still apparently a problem. Is it this entire test in general? Yes, this test in general is unhappy. So we need to put this here. Read byte. This is wrong. Okay, so we need to do this. And allocate one set so that fails because it's that. Okay, and then let's go find our test, which is this. And survey says, come on, new bike. Boom, we succeeded. So now let's clean up some of this here. We need to set this slightly better. Man, this is a thing, isn't it? Maybe this is the best it gets. we have to allocate the bytes. So let's do this one. So we have to do this every time. And what we need to do is we have to allocate bytes. This one's going to be a big old number. It's going to allocate 8 bytes. And instead we're going to write show. Set double. Like that. And we need to do socket stream update. So that will happen. Now, read double is this. So buffer input read double. So we passed. Yes. Okay, so moving on. Here. So essentially this. Connect a socket, we're going to kill that, and we're going to use this number here. And we should be writing 4 bytes. Set float. Told you after we got that update, these things would just move. And it took a while to get that right. And we're still not totally right, but we're closer. We have 2 loops that I'm not too happy about. Oh geez, okay. Floating point math error. That's awesome. Okay. That's fantastic. So what we're going to do is a number that was returned, we're going to multiply it by 1,000. And then round it. Math that round. Actually, we're going to do the floor. That's likely going to happen. Then we're going to standard int it, which I think will happen automatically. Yeah. So it already turns into an int. And then we're going to multiply it. Oh, we're going to divide it by 1,000. And how close did we get? Do we need to multiply by 10,000? $391. So what's the problem here? So we got, it definitely did some rounding. I think if we just do standard int here, we won't do any rounding. It'll just cut it off. There we go. Passing, passing, passing. Okay, so up to here now, should read an int. This is essentially this. There we go. We want 342. And this is going to be set int 32. And let's do it. And it's this one here. Buffer input. We have a couple more interesting ones to do. That's that. Okay, so we have unsigned short still, which is here. We're going to allocate this. There we go. This is going to be int uint16. And this is going to allocate 2. Update read unsigned short with 128. And it's going to go here. Read uint16. Hopefully no, 0. Find it hard to believe that. Oh. And buffer input. And there we have it. So, a couple more things that we didn't do, and by we, you, just kidding, is we need to check our bytes available. So our bytes available here, what happened here? Bytes available here is 1. Bytes available here would be 8. Oops. Bytes available here will be 4. This one will also be 4. Okay, make sure I didn't skip one. 4, and then this one should be 2. And that'll be it for the day. We'll be able to get most of this done, the rest of this done tomorrow. So there we go. So actually, let's look back. I think the only one we have that's weird, that's left, that I would be interested in is unsigned int. Let's take a look at our bytes set uint16. So I don't have a uint32 anyways. So we're just going to stick with that. It should get us most of the way there. We could probably do read TF bytes, read unsigned int, but we're going to kind of come back to these later. This is just going to be our current working stuff that we'll need just to get our game going. And we'll come back and finish this off. So let's commit this. Get status. It says get add sources, get add test, net, get commit, -m, added, reading from the sockets, tests. So get push. Let's do let's do date first. Get push origin master. Get tag 2016 0509 0842. Get push origin. And we have now added some read and write ability from our socket. So we'll do our integration tomorrow. Ooh, write float, that looks bad. If connected. Oh no, I don't need to do that. It's writing a double. Okay, so, which we apparently didn't have an output write float, right? Is that what would happen? Output write. Yeah, it was just write double, huh? write float. Yeah, it was like it was weird. Yeah, I was writing an int, so that's not wrong. It was weird. Okay, so there we have it. You guys have a great afternoon. I'll see you tomorrow and we'll get this thing rolling.